Okay, hello everyone. My name is David Zambrana. I'm PhD candidate in renewable energy and energy efficiency by the University of Zaragoza. Also, I'm a technical researcher and project manager of the Energy Resources and Consumption Research Center called CIRCE from the University of Zaragoza in Spain. And also, I have participated in several research and development projects at the European level and also at the Spanish level. And I have some papers, so I'm author and co-author of several publications and maybe some books also, and book chapters in life cycle assessment, waste prevention and management, and sustainable building assessment, and mainly energy efficiency and renewable energy policies. So today I'm going to present the lesson 2.5. It's called Enable Environment for Renewable Policy for Electricity and Heat Supply Sector. The outline of my presentation is divided in 5 sessions or 5 points. As first, the introduction, we are going to talk about the Europe's energy policy, the grid integration among European countries. Also, we are going to talk about the capacity market for grid balancing services, the regulation on grid access and charging, and finally, the regulatory framework for the grid extension. And finally, we are going to see which are the main actions to be done at the European level in the next year. So we are going to have some conclusions about this session. So we are going to start with the introduction. As introduction of my presentation, we are going to see a brief scope of the Europe's energy policy. We are going to say that over the last years, more or less 10 years, 10, 20 years, the Europe's energy policy has been geared towards achieving 3 main objectives. First, the energy in the European Union should be affordable and competitively priced. Second, the energy should be environmentally sustainable. And third, the energy should be secure for everybody. So according to 3 main pillars of the sustainability, we should focus not just in an economic point of view, but on environment and social issues also. But in this sense, a well-integrated internal energy market, it's a key topic for electricity and heat sector, and is the key to achieve these objectives mainly in a cost-effective way. So more or less in 2012, in November, the European Commission reported that the state of this internal energy market, mainly considering what has been achieved till 2012, and looking forward the next action, they have identified 3 main challenges to focus on the future work on. These 3 main challenges are the associated actions to be related with the need to implement, apply, and act in accordance with existing legislation. We are going to see in this presentation what kind of legislation. Secondly, there is a need to make the energy system fit for low carbon future. For example, focusing on renewable energy system integration to the grid. And finally, it's important to put the consumer center stage as the key enabler of this necessary transition, and also because it's the ultimate beneficiary of these liberalization efforts among the European countries. So a competitive and integrated internal energy market is an important component of this framework and will provide the necessary environment actions for future energy and climate policy efforts. So the main objectives considering the best cost-efficient manner. So these policy objectives, for example, if we took some example that recently happens with the Ukraine crisis, all the risk for security of supply was demonstrated what the European stands to gain from well-integrated and well-connected energy market with diversified supplies and solidarity in the face crisis. So in this sense, the European Union must continue to focus on the diversification of gas supplies, for example, on the construction of missing links to connected isolated areas, mainly on the developing of our own low carbon energy resources, and ensuring the integration of the renewable in energy and reliable manner. Mainly on increasing investment and smart grids. Smart grids is a key component of these policy objectives, and empowering the consumers and to equal application of the common energy laws across Europe. So the regional cooperation is crucial to achieve these objectives, and the recent crisis, as I said, with the Ukraine crisis, has demonstrated that it is no longer an option to act in isolation. So we need to think in regional cooperation, so policies objectives should help to reach those objectives. So nowadays at European level, more or less 20% of the electricity produced in the Union and 14% of final energy consumption over all sectors, if we consider all sectors, comes from renewable energy source. This means that the European Union is on the way to reach the target of 20%. This is the main target of energy consumption from renewables to the 2020. So this is the main goal where the European Commission is focused, even if further effort will be necessary to achieve this target. So if we think also further than 2020, it also provides an extreme basis to continue and reach more ambitious renewable target, let's say the 2030. And by this year, the European Commission has proposed to set such an EU-wide target of at least 27% of renewable energies on 2030. I put it in red in my presentation because this is a big challenge to think that we can reach 27% by 2030, but we are going to see if we are prepared, and also if the grid is prepared for this increasing of the renewable energy. So if the renewable penetration increase, it also raises some challenges. These challenges are because the variability and limited predictability of the solar and wind power makes more demanding to stabilize the grid. So as you know, solar and wind power are not constantly at all the time. So this variability is a limit to stabilize the grid. So the renewable generation and the European energy supply is moving away from thermal-based systems, and we are following the low emission systems with the renewable energy systems. So the configuration of the electricity supply in this case is changing. So based on the renewable energy directive, it is assumed that this renewable energy will provide about 35% of the electricity consumed by 2020. So we are thinking that we can reach the goal of the 20% of energy consumption from renewables by 2020. But this is probably become much larger after 2020 and will be the main component of the European power mix, mainly the electricity mix. So as my colleague says in previous lessons in this course, decarbonized power sector is the precondition to meet the mitigation target agreed with these objectives and also with the European Council 2009. It is focused to reduce emission in all industrialized countries, more or less between 80 80 and 95% by 2050. So we are talking about more deep in the objectives. I have talked about 2020, about 2030, and now we are seeing that the objectives of 2050 are much more higher. So the main question is not is such expansion of the renewable energy is technically feasible. The question is because some European projects and case studies has been demonstrated this technical feasibility. But the real question is what are the necessary steps to implement it without compromising the current level of the system reliability and actual infrastructures. So in this case, well-integrated markets plus regulation and grid access, grid extension and balancing systems are the key words in these new strategic interconnections in the European Union. So as an example, I'm going to talk about the Iberian Peninsula. Let's focus on the wholesale electricity markets. In this figure, you can see the monthly traded volumes and prices of electricity in the Iberian Peninsula. So you can see 4 years, 2010, 2011, 2012, and the first semester of 2013. And at the left of the graphic, you can see the wholesale prices in euros per megawatt hour. And at the right side of the figure, you can see the monthly traded volumes in terawatt hour. So in green, it's specified the Spanish volume, and in purple, the Portuguese volume. So Spanish and Portuguese base loads are represented with blue and red lines respectively. So more or less in April, you can see here April of 2013, the monthly average day-ahead baseline prices in Spain and Portugal fell to 3-year low. Fell to 18 euros per megawatt hour in Spain and more or less 16 euros per megawatt hour in Portugal, primarily owing to high level of hydro-based power in both countries. But as you can see, it's the down point of these lines. So abundant and cheap power in Spain provided good export opportunities to France, but it was not possible because the limited interconnection capacity and the preventing the French market for importing all that cheap energy was impossible. So this excess of power supply was unavailable in this region. So we can see that problems with the grid connection and interconnection capacities are reflected in some economic problems also, and well, are losses in the system, because if we have cheap power to sell, we cannot do, because the grid is not prepared to this exchange. So additionally, we can see in this map the extension, well, the commercial power flows between neighborhood countries. In most countries of the European continent, you can see in green the countries which are net exporter of power, and also in purple you can see the net important countries. So following the example with the Iberian Peninsula, you can see that mainly the Iberian Peninsula is a net importer of electricity. But you can see the many shares between the Central Europe countries, and mainly focus on France and Germany, that they are really connected with Central Europe, but in this case the Iberian Peninsula doesn't have many connections. So it's important to note, following this example, okay, that in comparison with Central Europe market, the Iberian Peninsula, it's, well, a net importer. So based on this figure, we can see that many problems on grid can be further compared with economic problems, also with social problems that European Union has to solve. So considering this cross-border trade in electricity between the most EU countries, okay, a bigger connected area will enable variability of the renewable sources. So as you know, the renewable sources are produced on local. So if we have a bigger connected area, we can include these renewable sources in the grid. So the cross-border trade in electricity between the European countries needs interconnections and needs to share these imports and exports, and also the total electricity available to final consumption should be increased in the 23 member states in this figure between the next years. So we are going to talk following this introduction with grid integration, saying that according to the loop flows, this is a final advice document prepared from FEMA report in 2013. It has been identified at 7 areas where significant development is crucial for the energy transition, from the isolated grid to the grid integration. So renewable generation, European energy supply is moving away from the thermal based and towards this new integration. So different incentives for investment in different countries and different times is needed, because we need this integration and we need it in all countries of the European Union. So the policies and support schemes have varied significantly over the time and between the member states. So creating different incentives for investments in different countries. Also, the grid configuration doesn't have rapid changes, so we need technologies that can have really rapid changes on the grid and in the distribution and electricity supply. We have to think in national basis, but in an European integration. So the inter-European grid structure is need to be developed. The transmission system operators cooperation is needed, because the transmission grids are operated on a national basis right now, and we need to distribute these costs and benefits of electricity flows, and can be controversial issues between power and neighborhood. So this is a real challenge for the European Union in the next years. In this figure, you can see these 7 areas where significant development is crucial for the energy transition. So we can see that in these 7 areas like power supply, demand, politics, markets, grid investment, grid operation, and allocating costs and benefits, we have the stage of before. For example, power supply, before, it's a significant amount of thermal and power generation, but in the future, it should be low or no emission system and large share of intermittent generation. I mean, with the renewable energy system integration, and also if we consider the second area, like demand, we can see that before it's a steady growth in the consumption, low demand flexibility, but in the future, this should be in the inclusion with the smart solution, demand response, and the distribution generation, creating new dynamic empowered system. So policies right now, for example, supporting schemes for renewable energy system are national based. But in the future, European policies should provide harmonized incentives and support the schemes for the integration of the renewable energy systems in the grid. Basically, because the market design and market monetary barriers because the markets are national power markets. So in the future, if we think in markets, common European market design and integrated markets should be aimed to optimize resources across Europe. If we think in grid investment, because we need to develop the grid integration at the European level, nowadays, before the national grid, it's nationally motivated by national investments. So we have limited interconnections. That's the case of the Iberian Peninsula. So in the future, the European Commission should plan a new grid investments aimed to optimize the resources across Europe. I mean, if some country has many solar resources or wind power resources, the grid it should be prepared for optimize these resources and to share among the European countries. So the grid operation in national transmission system operators with a national mandate should be go in the future with the transition system operator cooperating closely and acting as one transition system operator among the European countries. Finally, the allocation of the costs and benefits before was nationally based on tariff and short-term ITC compensation, but in the future should be mechanism for allocating costs and benefits and promoting energy efficient in European grid investments. So what's the third point of my presentation? It's the capacity market for these grid balances services, because the grid needs to be integrated, but we need some balances services to maintain the feasibility of the grid. So if we can see here, there is a schematic links between the transmission system operators and also with market participants for balances services. So if we can see at the top, we have the transmission system operator. So it's interrelated with the border capacity, the balancing services, and the system services access. So the final output of this interrelationship is the market participant, and all the collection is needed. So the base objectives are the profitability, the risk control, the level field access, transparency, the autonomy of the grid, because we need to follow the RES structure of the renewable energy resources that are local. And of course, we need some tools to connect the grid, tools to transact freely, and tools to dispatch all the power in the grid. So at the real time, balance between supply and demand, this is a main challenge of the balancing services. In electricity energy, for example, it's increasingly difficult for system operators we are including renewable energy sources. So if we increase the share of the energy sources with a variable output, mainly in wind, because mainly wind power has a variable output, it's not the same if we think in hydropower connection or just the thermal sources. So we can see that the balancing services as comparison in all countries, we can see the gate closure, for example, in day ahead, half an hour, 6 hours a day, that ahead, 1 hour, 2 during the day in different countries. And we can see the average transmission system operator sell price and the average buy price. So we can see the difference between both. It's the spread. This spread is like the price that we are going to, it's the benefits of this trade. So we have to think in not more in technical feasibility, but also we have to think in electricity balancing in Europe. So this market liberalization combined with a rise in renewable energy is constantly adjusting the design of the European electricity market. As a result of this adjustment, the ancillary services are becoming increasingly essential for this challenging market. So the transition system operators and system operators are the key actors of this integration. So they have to develop a balanced system in a review market design and also to provide interconnection through cross-border activity among the countries. So we are going to talk about the main regulation of grid access because, as I said, we need to access with the renewable energy sources and also considering the charging of this network and the grid access. So considering the grid integration of the renewable power sources, the main challenge as the integration was explained as follows, is there are three main topics, three main challenges to be considered when the adoption has to be done in the existing electricity grid. So the current grid is growing since the beginning of the electrification, and it's because it's based on large, controllable, centralized and fossil and nuclear power plants. So when we add the renewable energy sources, we have to integrate this capacity to the whole electricity system, and we have to think on redesign and to adapt the grid to handle these main challenges. One is the geographical distribution, because we know that the renewable energy sources are local. So the production and consumption of electricity changes with the introduction of the renewable energy sources. So this means that the electricity production and consumption should be close together, which makes an enforcement of the electricity grid necessary to adapt to a local production to a more decentralized production. So this is a problem of the next challenge focused on the distributed generation, because the small scale installations, mainly, I don't know, geothermal low temperature powers or other renewable energy sources that are called distributed generation, well, this capacity are mostly connected to the distribution grid. So this distribution generation causes a challenge for the distribution network, because they need to focus on the decentralized production. So if we think, for example, in solar and wind plants, the challenge is how to put bidirectional power flows in a connected grid that the infrastructure was built for one direct power flow. So there is a challenge in the distributed generation with the inclusion of renewable energy sources, which are connected to the middle voltage level. So finally, the third challenge is the variability and intermittency, because the renewable energy sources depend on the availability of the natural sources. For example, wind and solar power plants can only produce when their natural source is available. So there are at the same time variables and intermittent, and therefore not flexible usable of this energy all the time. So these challenges are represented in these tables that we have seen here, that this challenge of renewable electricity integration and related measures, it's mainly focused on the challenge, this geographical distribution, distributed generation, and variability and intermittency. But the measures, it's the expansion of the transmission network, the expansion of the distribution network, and the increased flexibility through the renewable energy sources power plants. the energy storage, the flexibility on the demand side, and the increased flexibility of the small-scale renewable energy sources. So we can see the different connections. I'm going to talk about the first with the expansion of the transmission network. In geographical distribution, we have to adapt the grid structure to connect new generation and demand, so to pass to decentralized system. Considering distribution generation, we have to think in generation in the distribution grid that is reduce the demand for transmission capacity. And finally, considering the variability and the intermittency, the expansion of the transmission network should be adapted to the grid structure to enable improved balancing between intermittent generation, let's say wind or solar power, in different areas, thinking about the renewable base load and thinking about the flexible resources such geothermal in this case. Is the case of example of this table, but not just thinking about in geothermal, but for example in wind and power and solar power generation. So following this table, there are some main principles. These main principles are focused on the regional approach. Okay, we have to have a level between nationality centralized and individually decentralized systems. We should consider the design, the electricity system, and how to manage the grid. We have to think about being sizable and controllable, flexible renewable energy system technologies, for example, biomass and hydropower, that can be reduce the need of installed capacity of gas-fired backup systems. Because as you know, we need some backup systems to cover the intermittency of the renewable energy sources. So flexible renewable energy sources technologies deals with both the transmission grid issues in the balance of the supply and demand, and also with the frequency control and different time scales. So the distribution grid has to be encouraged to the voltage control issues also. We need to have well integrated into electricity grid. For example, we have hydropower plants, but we need to balance the supply and demand of these systems with some changing systems. So I'm going to talk about the current state of the distributed generation in the main member states. I have put a link of the regulatory review and international comparison of the EU 15 member states. You can see here that the interplay of EU legislation, the national policies, and the general conditions for distributed generation. So if we think that the EU legislation, let's say the main directives combined with national policies and general conditions, puts into the status quo in the member states and also in the internal electricity market. So the interplay of this legislation with national and EU legislation have different national regimens. So the national promotion of the distributed generation, and also there are some policy recommendations, mainly taking into account national difference in promotion, because all the countries are different, but long-term creation of level playing in the with decentralized generation. So I'm going to talk about three main European legislation for the grid integration. Let's start with the main directive 2009-28, because it's the Renewable Energy Sources Directive. It's based on the promotion of the use of the energy from renewable sources, amend some other previous directive, for example, the 2001/77 and the 2003/30 directives. So the last one is this renewable energy sources directive. So this directive sets up a common framework for the promotion of the energy from renewable sources, which include wind, solar, geothermal, hydrothermal, ocean energy, hydropower, biomass, landfill, sewage treatment, and biogases. So they have many use of this directive focuses on the energy from renewable sources, but in our topic, in terms of the access to the grid, we have to say that the Renewable Energy System Directive stipulates that the member state should develop transmission and distribution grid infrastructure, intelligent networks, storage facilities, and an electricity system generally, so as to accommodate to further development of electricity production from the renewable energy sources. So this includes also the interconnection between member states and between the member states and third countries outside Europe. Also, the member states are required to grant priority access or guarantee the access to the grid system of the electricity produced from renewable energy sources. So we have to ensure that the transmission system operators give priority to generating installation using renewable energy sources when they dispatch electricity. So another main European legislation is this Directive 2012, number 27, on energy efficiency. Mainly, this directive is concerning common rules for the internal market in the electricity. But in terms of our topics, I said, in terms of access to the grid, there is a specific point that talk about the member state should particularly ensure the national energy regulatory authorities through the development of a network tariff and regulations. Okay, we are taking into account the cost and benefits of each measure. We have to provide, or each country should provide, incentives for grid operators to make available system service to the network users by permitting to implement energy efficiency improvement measures in the context of the continuing development, mainly of the smart grids. This is the Article 15 of this directive. So the directive concerning the common rules, it's also included in this directive of the energy efficiency. So as the next one, as I said, the third main European legislation, it's the Directive 2009, this number 72, concerning common rules for the internal market in the electricity. I want to put in focus on that in terms of the access to the grid. All the member states should encourage the modernization and distribution network, mainly in introduction of smart grids, which should be built in a way to encourage decentralized generation and energy efficiency. So at this point of the presentation, you can see that the main points of discussion is how to decentralize generation, how to integrate the renewable energy sources to the grid, how to interconnect better the European Commission or the European Union among the European countries, and also where rollout, for example, smart meters, its asset possibility. At least 80% of consumers, for example, shall be equipped with intelligent metering systems by 2020, but it's not the only measure that we proposed in this grid integration, but mainly in terms of charging, the rules adopted by the transmission system operators for balancing the electricity shall be objective, transparent and non-discriminatory, included rules for charging system users and their networks for energy imbalance. So in this final point of the regulatory framework for grid extension, I'm explain that there are some projects of common interest, the PCI. It's equals to contribute to market integration and competition, and as well to enhance security of supply and reduce CO2 emissions. So the European Commission have defined it in 2013 about 248 key energy infrastructure projects among European Union. I have put the link of this interactive map here in my presentation. You can go there and you can see the different key infrastructure projects that the European Union wants to develop for grid integration in electricity, in natural gas, in oil, and the inclusion of the smart grids among countries. So you will see the main infrastructure projects that are the key for the European Union for the next years. So you can go further for the link. So thinking about the current policies, what has been the success according to the European Commission and from the report? One of the successes was the prices. Let's think about 2008 and 2012, that the wholesale electricity prices are declined by 1/3 in this period. Also, the gas prices was remained stable. So, focus on the consumers. We have to say that consumers have more choice, for example, by picking an energy supplier. So this is a great success of the current policies in the European Union. So in infrastructure, many missing infrastructure links between European Union countries has been built or are under construction. As I said, there are many projects in the European Union that are key projects for missing infrastructure that will improve the integration of the grid. So the cross-border trade, mainly in gas and electricity between countries, have increased. So gas pipelines are also being used more efficiently, thanks because some common rules about the gas networks, for example, and also the European Union legislation has to prevent that energy companies cannot exclude competitors from access to the pipelines or the construction of important infrastructure. So the European Union rules also guarantee the fair trading about the wholesale markets and by preventing price manipulations. So what still needs to be done? But to complete the internal energy market, these further steps has to be taken and new challenges need to be addressed together. So according also the European Commission and their main reports on the topic, by 2020 we have to develop 3/4 of these EU infrastructure projects of common interest that you have this map of the right should be completed. This challenge to have the 3/4 of this infrastructure needs more investment in infrastructure, including also smart grids. In terms of gas, these investments should focus on ending the isolation of, for example, Baltic states, and to the diversified among countries the net generation. So in electricity, investment should be focused into linking the grids on the Iberian Peninsula We have seen the example of the Iberian Peninsula, also the Baltic region, Ireland, and the United Kingdom. So the implementation of this harmonized rule across Europe is also needed for gas and electricity trading. Finally, a stronger emphasis on regional cooperation. As I said, regional cooperation is key topic in this presentation to bring faster results and to have addressed local needs with the integration of the renewable energy sources. So the main objective, my main objective is that for 2020, these 3 quarters of the European Union infrastructure projects should be developed. So we are talking about several investments on the development of this infrastructure in the integration of the grid. We need this regional cooperation for better address local needs. Also, we need to, consumers should become more active players in the energy market. For example, considering smart meters, considering some social networks, and monitoring the grid. So they should come more active in the energy market as final consumers. So also the retail and the wholesale market should be better linked, because there are many differences between the retail and wholesale markets. So we need that to put the lower prices on the wholesale lead to lower consumer prices. We need to put together this on the same line, not to focus on the difference between the wholesale prices and the consumer prices. These are the main objectives of the European Union on developing for more sustainable renewable policy on the electricity and heat markets. If you have more questions, you can go directly to my email and ask me for further